Hello students, welcome to Sri Vardhaman Vidyalaya Online Education. Today we will start the chapter 13 of physics part Magnetic Effect of Electric Current. So in this part we will see the introduction. So as we have already studied electricity and its effects, you will be surprised to know that the magnetic effect and heating effect are after effect of current. In this chapter, we are going to focus on the magnetism produced due to electricity and also the electricity produced due to magnetism. So, let us study about the magnets and their property. At first, the magnet concept came into notice when it was observed that in the center of the earth, that is the core, and there is the substance that can attract certain substance toward itself, and that substance is regarded as a natural magnet called lodestone. Consider the properties of natural magnet. The man-made magnet were developed. So let us define magnet first. So magnet, it is the object which attract the pieces of iron, steel, etc. toward itself. Man-made magnets are of different shape, like bar magnet, a long rectangular pieces of magnet. So this is a bar magnet, and it is in a long rectangular. Next is a horseshoe shape or U-shaped magnet. So this is a horseshoe or U-shaped magnet. And next, magnetic needle. So these are the examples of the magnetic needle. So first we will see the properties of magnet. When a magnet is freely suspended, it always aligns towards north-south direction. So you can see that. So that is an bar magnet. It will be tied with a thread. So when it will be suspended freely, it will always align towards north and south direction. So this is the north pole and this is the south pole. Second, the like poles always repel and opposite poles attract each other. Now you can see that this is the north, so this will be the south of one magnet, and this is the south and this is the north. So this will, unlike poles, will be attract each other. Magnet always exists as dipole. So the magnet will have a two pole, one is the north and second one is a south. Two poles can never be separated. If we try to cut them also, both the pole will exist even in a small pieces of magnet. It automatically develop the lost polarity. So listen now. So this is a one bar magnet. If it cut into two pieces, what happens again? The south and north pole and south and north pole, that it will be gain their polarity. Here it is also, if it is cut again, what happens? It will be have their existing small pieces of magnets, and their two poles can never be separated. So it will have two poles, that is a magnet will has a dipole. A magnet always develops certain area around it where its effect can be felt, and that is we are calling as a magnetic field. Now you can see that the diagram, this is a magnet and this is the certain area around it which it effect magnetic effect will be felt. So you can see this is a magnetic pole and this is a magnetic axis and these are the magnetic field. So in this area what happens, you can find out the effect of a magnet, so that we called as a magnetic field. So magnetic field, it is studied by drawing an imaginary lines called magnetic lines of force. So this is you can see that is a magnetic field, how the magnetic field will be studied. So it is in drawing an imaginary lines called as a magnetic lines of force. So we are drawing this one. So the characteristic of a magnetic field, they always originated from north pole and terminate at the south pole. So you can see that magnetic field, they will be always originate. So it will be started from the north pole and it will be end at the south pole. In which two directions, you can see that it will start from North Pole and it will be ended on a South Pole. So this shows if the North Pole was free, it would have moved towards the South Pole. The place where they are closer indicates a strong magnetic field, that is at an poles. So you can see that at an poles, the magnetic effect is very strong than that of another side. So you can see this one. There is an place where the closer indicates a strong magnetic field, that is at an pole. The magnetic field lines gives the directions of magnetic force. So using a magnetic field lines, we can find out the direction of force. The two magnetic lines will never intersect each other as they give the direction of force, and the force cannot have two directions at a time. So here you can see that any two magnetic field, they will be never intersect. So it will not intersect each other as they gives a direction of force, because the force cannot have two directions at a time. The magnetic field lines are closed continuous curve. So this is a closed continuous curve, and the magnetic lines produced around a bar magnet. So these are the characteristic of a magnetic field. Now we can see the activity 13.1. Take a straight thick copper wire and place it between the point X and Y in an electric circuit, as it will be shown in the figure 1. Place a small compass near to this copper wire so that the position of a needle. So see the position of its needle. Pass the current through the circuit by inserting the key into the plug. Observe the change in the position of the compass needle. So observation, the current flow from positive to the negative and the current flow from X to Y and the needle deflected to the right. Now you can see this one, the circuit. So in this one, we are keeping a thick copper wire, and that will be, so this is a thick copper wire and that will be placed in between a point X and Y. Okay, now the electric current will be passed. So the XY is kept perpendicular to the, so this is a paper, so XY will be kept perpendicular to the plane of a paper. So place a compass needle near the copper wire. Now you have to see the position of a deflection. Now passes the current by inserting the key into the plug. So what the observations you have to find, that is a change in the position of the compass needle. Yes, so you can see that is the current is flowing from a positive to the negative. So the current, you can see the directions, the current will be flowing to the positive through the negative, and the current that will be flow from X to Y, then the needle deflected to the right side. So when the current will be flow from positive to the negative and flow from X to Y, what happens? So the magnetic compass needle shows a deflections to the right side. So the compass needle deflects as the current passes through the metallic conductor. So when the compass needle will deflect when the current is passes through the metallic conductor, so it means that the electric current through the wire has produced a magnetic effects. So from this experiment we can find out that is when the electric current will be passes through the wire, it will produces a magnetic effect. So the compass needle is deflected and passing electric current through the metallic conductor. So this is the circuit for this one. So Hans Christian Ørsted, so in 1777 up to 1851, Hans Christian Ørsted, one of the leading scientists of the 19th century, played a crucial role in understanding the electromagnetism. In 1820, he accidentally discovered that the compass needle got deflected when electric current passes through the metallic wire placed nearby. So, through this observation, Ørsted shows that the electricity and magnetism were related phenomena. His research later created the technology such as radio, television, fiber optics. So the unit of the magnetic field strength is named the Oersted in his honor. So the Oersted is he is one of a leading scientist of 19th century and who has understood the electromagnetism. So in 1820 he discovered a compass needle got a deflected when electric current is passes through the wire. So this observation shows that the electricity and magnetisms will have some related with each other. So you can see this diagram. So this is the photo of an Oersted. So he's first discovered that is this is a metallic wire conductor through an iron. So he placed on a compass needle. When the electric current is passed, what happens? That is there is a magnetic effect you can see. So this effect will be shown by a needle. So that is a compass needle got deflected when the electric current is passes through the metallic wire nearby. So this is the first discover by an Oersted. So the unit of a magnetic field strength was an Oersted, so it will be given in the name of his honor. So this is our first part. So hope you have understood the general introductions about the magnetism, properties of magnetisms, magnetic field, and how the how when a current pass there will be some magnetic effect will be seen. Thank you. We will meet in the next part of this session.